Alright, so now we're on to lesson 3.6, sine function transformation. So basically we're combining what we did in the last one and adding just a little bit more transformations, right? So we're used to seeing the A, the B, and R plus D, but not kind of all of it together. So for our sine graph, I'm just going to go over the key points again, but this time for when A is above 0 and for A is less than 0. So this is positive or negative. So whenever A is above 0, so this is like our standard sine graph, right? We start out at an intercept, we go to a maximum, we go back down to an intercept, we go to a minimum, and then back up again to an intercept. But if it's negative, it'll still start out at an intercept, but instead of going to a maximum, we'll be going to a minimum. Back up to intercept, back up to a maximum, and then back down to an intercept. And then over here on the right side, I'm going to label a few things, right? This is going to be helpful for figuring out what A, B, C, and D are, right? C is where we're starting. Like C is our start point. Because typically we start at like 0, right? But C is going to be our shift horizontally, right? And then of course A is still our amplitude, absolute value. Y equals D, that's our midline. And then of course our period is 2 pi over B. So this C is really just something a little bit extra. Alright, and now onto a cosine graph. Our key points for just a regular standard positive cosine graph, we are going to start out as a maximum, then go to an intercept, minimum, intercept again, and back up to a maximum. Right, but then if it's negative, instead of starting out at a maximum, we'll start out at a minimum. Then intercept, maximum, intercept, back down to a minimum. Alright, so same, everything is just labeled the same here as the first diagram, right? C is our start point. A is our amplitude. Y equals D is our midline. And 2 pi over B is our period. Alright. And then these are just some reminders of what the words are that I'm saying. Right, we're familiar with amplitude, period, midline, and our B terms. At phase shift, we haven't, I mean, we've talked about the concept before because it's shifting our graph left or right, but it's new for this unit. Right, so the horizontal translation for the cycle, and specifically negative, right? Because everything inside the parentheses that's happening in the parentheses, let me underline what I'm talking about. It's opposite of what it looks like. Alright, let's go on to the next page and actually start on an example. So note that we have parentheses here. Like, this is the graph of y equals a sine, and then in parentheses, b times x plus c. So this you'll have to pay close attention to. This is something to where there's a code on IXL for this, but the way it does it is not the same as the way we do it in that. Basically on IXL they distribute that b. So instead of b and then parentheses x plus c, it's like b times x plus b times c. But we're gonna do it this way. Alright, so this is a horizontal shift of the graph a sine bx. And our starting point of the cycle is shifted from x equals 0 to x equals c. And we can find that interval containing one cycle by solving the argument for the period 2 pi. And this gives us the starting point and the ending point for one period. And now we've got this. Graph y equals 3 sine 3 times x minus pi over 6. So we got to unpack this. They're giving us a lot of things. Like we almost have every transformation possible except for a reflection. So let's find out things that we're used to finding out for now, right? The fact that this 3 that I'm pointing at here, that's going to be our amplitude. So we know that our amplitude is equal to 3. All right. But then we have everything in our parentheses here. So we know that this 3 in our parentheses is our b, which means our period is 2 pi over b. So our period is going to be 2 pi over 3. So that's the length of one cycle. But then we have this x minus pi over 6. That x minus pi over 6 is now going to be our shift. So x minus pi over 6. So it means our x is equal to pi over 6. That's our start point. So instead of starting at like the origin for a sine graph, we're actually starting at pi over 6. So now from here, we can figure that out. But let's figure out where we have to stop. So we know our start point, and our period is 2 pi over 3. So to figure out where we're stopping, we're going to take our start, which is pi over 6, and to just add our period to it. Pi over 6 plus 2 pi over 3 is going to get us, let's see, 5 pi over 6. So that's our stop. So I'm going to put a dot on there as well. And I'm doing it here because I know based off what they gave us, they did not give us like a plus d here. So I know that we're going to do everything at the origin. So there we go. The red dot and the green dot is just one full cycle there. Okay, cool. So now let's graph it. Let's see. I'll do blue. So I'm going to know that since that's one full cycle, we're definitely going to have an intercept at pi over 2. And then since our amplitude is 3, we know that we're going to have 1 point up here, so over pi over 3, up 3, and then 2 pi over 3, down 3. So these are our points. So I'm just going to graph one full cycle here. So there we go. That's it. Technically it does, like, you know, it keeps going, but because it's a sine graph and it doesn't specify. But technically, if you just graph one period, 2 pi, oh, that's not pi, 2 pi over 3. But it'll keep going. Most of the time, it will show you the graphs continuing, say for like multiple choice answers. But there we go. That's how you graph it. All right, and now we're going to switch over to a cosine graph. So same situation, except now we just have to remember our rules for cosine. All right, so let's find out what we do know, what we're familiar with, right? And that is the fact that there's a 2 right there, so that means our amplitude, it's going to be 2. And then let's figure out what our period is. So we know that our b value is equal to 1/2. So 2 pi over b for our period is 2 pi divided by 1/2. So whenever you divide by a fraction, you flip it, meaning that instead of 2 pi divided by half, we'll do 2 pi times 2, which is equal to 4 pi. So that's our period. Okay, cool. So we know our period, we know our amplitude. Normally that would be everything we need if there wasn't any shifts going on, but there is because we have x plus 2 pi. So this x plus 2 pi is going to determine where we're going to start our graph. You basically just solve for x here. So x plus 2 pi equals 0, which means x is going to be equal to negative 2 pi, which is where we start. So, and there is no vertical shift here, so I'm going to use what I know about cosine graphs, and that the fact that a positive cosine graph is going to start out at a maximum. So if our amplitude is 2, that means it's going to start somewhere along this line here, and we know that our start is negative 2 pi, so let me erase that line. So this little green dot here is where our cosine graph is going to start. And if our period is 4 pi, we know that it ends right back at a maximum. So I'm going to, well, I'll do the math for it, but 4 pi is a nice easy number. So what we do to find the stop is we're going to take our start point, negative 2 pi, and we're going to add our period. Right, we just added the period to that. So our stop point is 2 pi. X equals 2 pi. So that is right here with our amplitude of 2. All right, cool. And then we can fill in the blanks knowing the other key points of our cosine function. The fact that it goes maximum, intercept, minimum, intercept, maximum again. So I'm just gonna, I like to start from the middle. So I know that we're gonna have a minimum right there at negative 2. So the in-between point of negative 2 pi and 0 for our intercept is gonna be pi. Negative pi, sorry. And then from 0 to positive 2 pi is gonna be this positive pi. Alright, and it's not a V, so let's just kind of try our best here. There we go. And that is our cosine function. Awesome. So now we're going to compare and contrast what occurs to the period when b is greater than 1 to when b is in between 0 and 1, right? So whenever b is greater than 1, that is a horizontal compression, right? It squishes. And then whenever we're in between 0, excuse me, 0 and 1. Oh, I did not mean to go to the next page there. Let's zoom back in. Zoom back in. All right. Whatever between 0 and 1, that's a horizontal dilation. All right. And then now we're going to talk about our C values, right? When the argument is C is less than 0, then our phase shift, remember it's always opposite of what we think. So whenever that C value is negative, we're going to phase shift over to the right, which means when our C value is positive, we're going to phase shift over to the left, right? All of these follow the same exact transformation rules as what we are used to seeing with any other type of function. It's just now sine and cosine. All right, so I'll move on again. So now we're going to do that vertical shift. So if you add or subtract a number from the entire equation, so that's the thing all the way on the furthest right side, outside of parentheses, we can shift everything up or down. All right, this makes our midline not the x-axis, basically. So we're going to just do that to two basic sine and cosine functions. So for example 3, we have y equals sine x plus 1. So that plus 1 means up 1, right? So this is up 1. So sine always starts at a intercept, but since our midline is now not the x-axis, we're actually going to need to start at 1 right there. And then this is just a normal sine graph, so that means our period is going to be 2 pi, so I'm putting my end dot there. And I know that we're going to have another intercept here. Intercept on the midline. Let me write the equation of that. And then we're going to have a maximum, and then a minimum. So there's our little outline of our graph. There we go. And then, you know, it's going to keep going. So there we go. There's our sine graph, just shifted upwards. We know our amplitude is 1 because there is no number in front of the sine. It's just 1. Alright, so now on to our cosine graph. This minus 2 means we're going to shift down 2. So our new midline is going to be this negative 2 here. So y equals negative 2. And then with cosine, we know that we start at a maximum if our if our a value is positive, in which case it is. It's just pretty much just a parent function with a shift downwards. So we're going to start at a maximum, so -1, and then we know we're going to end at a maximum at our period of 2 pi, so I'm covering that number up right now with my little dot. And then our midpoint of our period is just going to be a minimum, and then we have our 2 intercepts. So this right here, what I'm doing, I'm using our knowledge of a cosine function to kind of fill in the gaps there. Oh my, this is why I need to put the points. Hold on. There we go. We fill out the rest, and there you go. We graphed it. We shifted up 1 for sine and then down 2 for cosine. Alright, and then we have this kind of summary area here. So given the standard form of a sine or cosine function, complete the summary in the table below. So this is everything kind of like what we've learned here. So our variable expression for amplitude is going to be our a value. And then explain the effect of this transformation on the parent function, like verbally, like what's happening if that amplitude moves. Basically, it's, or just kind of what it is, right? Amplitude is half the height of our like wave, like of our squiggly. It's a vertical dilation. So half the height of our wave. It's a vertical dilation. Alright, and then for our period, that is going to be 2 pi over b. And also, our period's always going to be technically positive because, like, usually it's actually absolute value of b. I know I haven't mentioned that before, but if a period's negative, it effectively just means the same thing. It's just like the length of a cycle, so that's why we just talk about it in positive terms. But yeah, so 2 pi over b. So it's not b. So this is the only one. Like, notice of our a, b, c, d values, the one that we're having to change to find our information is going to be for our period. So this is just the length of one full cycle, right? Of one full cycle of the wave. Alright. And then this one also has to do with like compression, right? So our horizontal dilation basically is that. Alright, and now let's talk about our phase shift, which is our C. So this is our horizontal shift. Horizontal shift, and it's our first key point of our cycle. Of our cycle. Okay, cool. And then finally we have our vertical shift, which is just our plus or minus d at the end, and that's our midline. And it moves the x-axis up or down. I mean, not x-axis actually. It just moves our midline up or down. So this one's our vertical shift. Alright, cool. So that's our summary. Alright, let's do lesson 6B in the same video, because why not? So now we're on to finding an interval for our first cycle. So this is kind of where I was talking about we can do things in different ways, because this is math, and we can do everything in a million different ways, right? So we can find our endpoints for our first cycle of our trig function in 2 ways. method 1 and 2. So basically our period begins with our C value, right? Same with method 2. And then our period ends at C plus 2 pi O for B. Whereas method 2, it just ends at 2 pi over B. Again, technically absolute value there. We do not want a negative. So I'll explain this in math. Right? It says, note, use the first and last points of one cycle to divide the interval into 4 equal segments. That's just helping us find like the midpoints and all of the other things. All right, so find the amplitude period and phase shift for that function. All right, and then also graph it. So our amplitude, we know, is going to be the absolute value of that 2, so it's 2. All right, and then our period is going to be related to our B value here. So period's 2 pi over B, and we know that we have 2 pi over 2, so that means our period is just pi. And then our phase shift, we have x plus 3 pi over 2, 3 pi over 2, which means our x is going to be negative 3 pi over 2. So technically that's 3 pi over 2 to the left. So let's graph it. Let's see. And this is a cosine function. So let's see what we are going to do here. We're starting at negative 3 pi over 2. But since it's cosine, we need to start out at a maximum value. So I'm going to do a maximum value at our amplitude. Oh, my bad. I read the scale wrong for a second. This is where our dot should be. Watch out for the scale. I accidentally put it at 1. Right? Because we start out at a maximum. And then if our period is pi, so if we add pi to negative 3 pi over 2, we are going to get negative pi over 2. So I'm going to put our other point there. Okay, so that's how we find our stop point. Okay, and then based off of just our key points normally of our function, we're now going to figure out, like, basically we split it down the middle to get our middle key point. You know, that's going to be our minimum in this case. So our minimum is going to be at negative pi. And then we look at the midpoint in between our starting and our middle point, which will be right there and right there. So there we go. That's our function. So let me just graph that really quick. And again, typically with these, you do finish graphing the whole thing, like the entire way. But for the sake of our time, I will stop. But just know that, here, let me highlight it. Our period of this function is from this line that I drew to that line that I drew. This right here. That's one period. Okay. Ooh, so now we're going to just describe our transformations in words. So we're given this sine equation that has almost every type of transformation. We're just missing one. Right. Describe the transformations that occur from the parent graph and then sketch it. All right. So the first thing I like to look at is like our just from left to right, right? So that negative in front of that 2 means that we're going to have a reflection. So we are going to reflect across the, anyone remember if that's X or Y? It's outside of our parentheses, but this is the one where it's opposite of what you think with the reflection. So this is reflecting across the x-axis. All right. And then we have that 2 there. So that 2 is our amplitude. So that is our vertical dilation. So So we have a vertical dilation by a factor of 2. All right. And then let's just talk about the period, right? So our period is pretty much just our like stretch factor in a way. So our period is going to be, right, we have 2 pi over b. So that means our period is 2 pi over 3. And then finally, where we're phase shifting, right? This is where we start or stop. So if we have x minus 2 pi, that means we have a phase shift 2 pi to the right. So we start at x equals 2 pi. And then we stop at 2 pi plus 2 pi over 3. 2 pi plus 2 pi over 3. All right, so let us graph it. So negative sign, we're still going to start at an intercept. And that's because we don't have a vertical shift. We just have vertical dilation, horizontal shift. So if we're starting at 2 pi, that is going to be right there. But I mistakenly did plus 2 pi over 3, but since our scale kind of stops at 2 pi, I should have done minus 2 pi over 3. So I'm going to erase that. Sorry, guys. Minus 2 pi over 3. So 2 pi minus 2 pi over 3 is going to get us, I believe, 4 pi over 3. So 4 pi over 3. And that is our stop point. So that's the length of one period. Okay. And then let's just do our sine graph here. So I'm going to start from 4 pi over 3 because it's effectively the same thing. I'd rather work forward than backwards. So since our sine graph is negative, instead of going up, we're actually going to go down our amplitude. So our amplitude is 2. So we're going to go down all the way to there. And then we go back up to a midpoint. And then we go up to a maximum. And then back down. So that right there is one period of our graph. And then I'm just going to kind of sketch out a little bit of some more of this graph, basically. But I have to do the key points here. So we're going to finish that. Go this way. Back up this way. Just a nice big squiggly line. Oh, that was not curved enough. But yeah, there we go. There's our sine graph. And then let's do our little arrow because it doesn't stop, right? It just keeps going on and on and on. Okay. Let's see. Let's look at this example. Ooh, this one does stop. So this is a good example of where it does stop. It says graph the function from 0 to 12. Okay. So I am just going to slowly do this problem and show you the answer in a moment when I'm done, because I think you guys can totally do this, right? Determine amplitude, period, midline of that, and then graph it. So I'm going to work on this problem while you also work on this problem, and I'll skip ahead to the answer. All right, so that's the answer. There you go. So we had to start at a minimum this time because of that negative, so we had a reflection there. And then our period was 6, midline y equals 3, amplitude is 2. All right. So now we're going to go on from writing functions just from descriptions. So no visual graph, just words. We're given everything we could possibly need to write a sine and a cosine function here. So let's take a look at it. So it tells us the sine function, and then it says we have an amplitude of 3, period of 2 pi over 3, a phase shift of pi over 3 to the right, and no vertical shift. So that's all it's giving us. So we're going to use our knowledge of our y equals a sine bx plus c plus d to complete this. So our amplitude is always going to be our absolute value of a. It's not calling out any sort of reflection here, so we can assume that our a value is just going to be 3. Alright, and then we have sine b. So we're given our period, but we're not given our b value, so we need to work backwards, right? If we know that our period is 2 pi over b, and our period itself is 2 pi over 3, then that means our b value is 3. So we can plug that in. Then we have x, and then it says pi over 3 to the right. So since it's to the right, that means this needs to be a minus pi over 3. And then plus d, that would be our vertical shift, and there is none. So we don't do that at all. So there we go. That is our sine function from just a description. All right, let's look at our cosine function now. So amplitude 5, period 4 pi, phase shift pi over 4 to the left, and vertical shift of 2 down. So let's start to plug that in, right? We have y equals a cosine b x plus c plus d. So those are the things that we're filling in. We're going to be confident that 5 is our a value. Cosine b. Once again, we have to figure that out. So our period is 4 pi. And we know that you calculate that by doing 2 pi over b. So that's telling us, if we solve for b here, that's telling us that our b value is a half. Okay, so I'm going to put in 1/2, and then x, and this is saying pi over 4 to the left. So that means we're going to do plus pi over 4. Close that bracket, and then this time we do have a vertical shift, 2 down, so that's minus 2. And there we go. That's our cosine graph. Okay, so we're going to just skip example 11 and move on to example 12. Alright, so 12a. I'm not going to do 12b, just 12a. So find an equation for each graph, just the one. State the amplitude, period, phase shift, midline. Verify our equation with a graphing utility. State the maximum and minimum points in one period and the points of inflection. So we're just given a visual here. So let's see if we can figure it out. It also doesn't tell us whether or not to give us sine or cosine, but I can say right off the bat, if this thing is starting us off at an intercept, then I'm going to call that a sine graph. So the first thing I looked for there was our midline, because that's going to help kind of base everything around it. So we know that our midline is y equals 3. And then from there we can figure out our amplitude, right? So our amplitude is going to be, it looks like 2, right? So our amplitude is 2, absolute value. All right, and then it also says state maximum and minimum points in one period and the points of inflection. Like, there's a lot it's asking for, so I'm just going to try to find everything. So I'm going to write it out in the order. So we have amplitude is equal to 2. All right, period. Let's see, is equal to, it looks like it stops right there where I just put my dot. So it looks like from 0 to 4 pi is 1 complete period. So that's 4 pi. All right, phase shift. I'd say none. We don't have a phase shift, so I'm gonna say 0. All right, and then midline is y equals 3. Okay, so we said that. And now let's write that into an equation, since that is the first thing it asks us to do. All right, so we know y equals a, and I want it to be sine b x plus c plus d. Okay, so y equals, our sine graph is going down instead of going up from the first point. So that means this is a negative. So our a value is actually -2 sine. And then b, so to get b, we know that the period's 2 pi over b. If our period's 4 pi, that means we're going to have to, it's going to be like a fraction. So our b value should be 1/2. So sine 1/2, and it's just going to be x, and then plus 3 with our midline. So y equals -2 sine, I'm just rewriting it, 1/2 x plus 3. The way I wrote that's bothering me. Let's fix it. Alright, so this is something to where your answer based off the way that you're solving this problem could be different from this. Because remember how I said that a sine and a cosine graph are just the same thing but shifted? Right? So you could have started it at, I don't know, at pi and said that this was a cosine graph that had a shift over to the right by pi units, and then figured it out that way. But then like the end of your cosine graph would have been off the screen. But just know that there are multiple valid answers to these problems, right? So that's our answer there. You can double check that on your graphing calculator if you wish. All right, and then it's going to ask us for our maximum and minimum points. So if just looking at our graph, our maximum is going to be 5. Our minimum is going to be 1. Then it also wants our points of inflection. So it's just wherever we change concavity, right? So every time we change concavity, it's just going to be starting from 2 pi, and then just every single time it's plus 2 pi. Like plus the period, pretty much. I mean, our period is 4 pi. What am I saying? My bad. But yeah, points of inflection, let me color that green, right? We have a point of inflection there, we have a point of inflection there. Technically, we have one all the way at 0. So it's just every 2 pi intervals is when it swaps. So 2 pi plus, technically it's plus or minus 2 pi times k, with k being like pretty much like all real numbers, right? Like every cycle. And then usually we answer this in coordinate form, and this is up 3, right? So that's our x value. Like this is our x, and this is our y. All right. So again, with example B, I'm not going to verbally walk you through it, but I will show you the answer. So you work through this problem as I also work through this problem, and then cut to the right answer. Okay, so that is the answer that I came up with for B. So I chose to just start at the y-axis because I don't know, I just like to do that. So because I chose to start at the y-axis, this turned into a negative cosine graph, which I initially forgot to write my negative sign there. But this is a negative cosine graph because normally cosine starts out from a maximum and then goes to an intercept, minimum, intercept, maximum. But since I chose to start this on the y-axis, so this point here that I'm starting at, that is how my equation ended up looking the way that it did. If you got something different, that does not mean that you did it incorrectly. Some of you may have started it off from, say, right here, where I just put my little star. Some of you may have also started it off from right here, where I'm drawing my arrow. If you did, you would have gotten different things. If you started it off where the star was, you would have ended up with a sine graph that was positive and had a shift over by pi over 4. By shift, I'm talking left and right. Because no matter which one, you're always going to have a vertical shift downwards. And then if you started it where my arrow was, you would have gotten a cosine graph, but it would have been positive, and you would have had a shift of pi units to the right. So just know these ones are a little bit more open-ended, which is why most of the time they will be multiple choice questions and not free response, because then there's just so many different combinations of things. But anyways, so that's it for lesson 3.6, and I'll see you in 3.7. Bye.